Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss realizing logic gates by using diodes. Let's begin. In logic circuits, we use diodes and transistors. In this way, we have to realize the logic gates by using diodes. Let we consider a PN junction diode. Or we can say just like a simple diode. In electronics, the PN junction diode just act as that acting like a switch. How? We consider the idealized diode, means that conduct in the forward direction with no voltage drop and do not conduct current in the reverse direction. Symbolically, that is a PN junction diode. Here P, that line referred as N. Here P type semiconductor and N type semiconductor are used. And that P type is known as anode, N type is known as cathode. When that P type is connected to the positive terminal of the battery and N side is the negative terminal of the battery, P type connected positive terminal of the battery, N type connected negative terminal of the battery. Or we can say P type, that is the anode, N type is the cathode, that is cathode connected to the negative terminal and anode connected to the positive terminal. Then that interface offers no resistance, so that diode can conduct current, and that is known as the forward biasing. Here current conduct, means conduct current through that of junction diode, and that diode acts as a closed switch. It is acting like a closed switch. In other words, technically we say the diode is an on position. Diode is switched to on position. In binary bit we represent that kind of electronic state as 1. In binary bit it is designated one, that is close switched on and 1. In other hand, when that PN junction diode P type is connected to negative terminal and N type is connected to the positive terminal. In other words, that anode is connected to negative terminal and cathode is connected to positive terminal. In that a particular case, that interface offers very high resistance and that biasing is known as reverse biasing. And here that not conduct current. It just act like a open switch. And in other words, we say that diode is switched to off position, and in binary bit it is represented by 0. Combining these actions, we say in forward biasing situation current flows, and in reverse biasing situation it does not flow current. That is the switched closed switch condition, that is the open switch condition. We say it as on, that one as off. Binary bit it is represented by 1, it is represented by 0. Overall, the PN junction diode is just acting like a switch in an logic circuits. Let we discuss how we realize the logic gates by using the diodes. By taking OR gate, realizing OR gate by taking diode. In truth table, we know OR gate as 2 inputs, the symbol of OR gate, it has 2 input A, B, output Y as A or B. So, input A, input B, output Y is equal to A or B. The possible situations 0 0, 0 1, 1 0, 1 1. In OR gate only when two inputs are 0, then the output is 0, otherwise it will be 1. Now we have to realize all these situations by taking diodes. The first 0 0 situation, taking two diodes, D1, another diode D2, the voltage source plus 10 volt, here 0 volt, and that diode, that arrowhead, basically a notation in that diode, arrowhead represents the forward low impedance direction of that current flow, the flow of current. Next, for that of D2, plus 10 volt, it is grounded as 0 volt. Here input A, input B, 0 volt, 0 volt means A input as symbolized as 0, B input as 0. When these two are connected, across a resistor R, it is grounded, at that of resistor voltage as V output, look here, when 0 volt is applied as inputs at the anodes of both the diodes, both the inputs are at 0 levels. We label the two inputs A and B as A is equal to 0 and B is equal to 0. Here the OR gate represented as A is equal to 0 and B is equal to 0. The cathodes of these two diodes are connected to the ground through a resistor having resistance R. Connected it to ground, and the output is taken across that of resistor. Here both the inputs are low, 0 volt, 0 volt, low inputs, and that is set in the reverse biasing condition, for reverse biasing condition, both are treated as switched off. As we discussed earlier, reverse biasing condition, both are treated as switched off positions, hence they do not conduct current through that of resistor R, and here the potential drop V is equal to 0 across that of resistance. So, the output voltage is equal to 0 volt. In binary notation, the output voltage level is treated as 0. So, Y is equal to 0 if A is equal to 0 and B is equal to 0. In this way, we realize OR gate by using diodes. Next situation, for 0-1 condition or 1-0 condition, 1-0 condition, similarly D1, D2, ten volt, zero volt, input A, next 10 volt, zero volt, input B, here A as 1, B as 0, A as 1, B as 0. It is grounded. Here we measure V output. Same condition, that is forward bias, that one is reverse bias. Here is the position on, here is the position off. Therefore, the potential drop across V output is equal to 10 volt. Therefore, it uses the condition as A is equal to 1, B is equal to 0. Therefore, Y is equal to 10 volt, that is represented as 1. Similarly, for another situation, if A is equal to 0 and B is equal to 1, just its reverse condition. In similar pattern, in that of output voltage, we have 10 volt, means one is off but another one is on. That close that of circuit. In that of case, it is switched on condition, and at V output the potential drop is 10 volt. In this way, we realize the OR gate by using diodes. Last case, 1 1, two inputs are 1, means two diodes are in forward biasing situation. Considering D1, D2, potential across 10 volt, 0 volt, since it is one situation, so that for 10 volt, 10 volt, 0 volt, again the arrowhead towards 10 volt, input A and input B. So, the output across that of resistor R, which one is grounded, V output D1 forward wise, D2 forward wise, this is condition 1, this is condition 1. So, the output, the potential drop across V output must be 10 volt. The entire circuit is closed. Therefore, for that of OR gate, when A is equal to 1 on, B is equal to 1 on, then Y also on 1. In this way, we express OR gate in terms of diodes. Next situation, for AND gates, how we realize AND gates? By taking diode into our considerations. AND gate. For AND gate, the symbol of AND gate it has two input as A and B, output Y is equal to A dot B, read it as A and B, and in truth table A, B, Y is equal to A and B. Possible situations 0 0, 0 1, 1 0, 1 1. For AND gate, that results 1 when both the inputs are 1, otherwise it will be 0. Let we understand, or we can say let we realize the AND gate by using diodes. In similar pattern, here the diode, that is the N type, D1, another diode D2, both diodes, here the input towards the diode through their cathodes. Voltage source plus 10 volt, 0 volt, plus 10 volt, it is grounded, that means it will be 0 volt. Here the input A, another input B. So, let we prefer first condition of AND gate. For 0 0 situation, if A is equal to 0 and B is equal to 0, then what happened to that of output? When A is equal to 0, B is equal to 0, the arrowhead towards 0 volt. Two are connected, and here we have to take in V output. And a resistor is connected. What will be the potential drop across potential drop, your 10 volt potential, A is 0, B is equal to 0. Both inputs are 0. When 0 volt is applied as inputs at the cathodes of these diodes D1 and D2, both the inputs are at 0 level. We label the two inputs as A is equal to 0 and B is equal to 0. The anodes of the diodes are connected to the ground through that of resistor having resistance R. So, the resistor R is connected to that of 10 volts to provide the forward biasing situation, means forward biasing current for the diodes and the current for output to drive. With the cathode at ground level, both the diodes are in forward biased. They conduct current through that of resistor R. Therefore, two diodes are grounded, causing 0 potential at the meeting point of these two anodes. Here V output was 0 volt. So, the output voltage with respect to ground becomes ideally 0. Therefore, here Y is equal to 0. In the first situation, when both the inputs are 0, then the output is 0 for that of AND gate. Next, another situation when 0 1 condition, now what happened? Similar fashion, anode, cathode of that of diode D1, D2, plus 10 volt, 0 volt, plus 10 volt, 0 volt, here the situation of AND as A is equal to 1, B is equal to 0. So, A is equal to 1, arrowhead towards 10 volt, B is equal to 0, so arrowhead towards 0 volt. Both these two are connected across V output resistor R towards a potential 10 volt, taking that into forward biased. At that of situation, here on output we have 0 potential, since the diode D1 behaves as an open switched and D2 behaves as a closed switched. the circuit is completed with D2 and R through that of ground, hence D2 conducts and it is grounded, then the output voltage becomes 0, here Y will be 0. In the reverse manner, when D1 is equal to D1, in that of D1 the input A as 0, in D2 the input B is equal to 1, means A is equal to 0 and B is equal to 1. At that of situation, D1 behaves as a closed switch and D2 behaves as an open switch, and that of circuit is completed through D1 and R through that of ground, and D1 conducts and is grounded, then the V output will be 0. When A is equal to 1, B is equal to 0, so V output is 0. In that of reverse manner, when A is equal to 0 and B is equal to 1, A is equal to 0 and B is equal to 1, also the output will be 0. Last situation, when both the inputs are 1, then what happened to that of output? D1 D2 plus 10 volt 0 volt plus 10 volt 0 volt, both the inputs are 1, arrowhead towards 0 volt, arrowhead towards 0 volt, input A, input as B, these two are connected. As V output through that of resistor R, here the potential plus 10 volt. Then the situation for that of AND gate, A is equal to 1, B is equal to 1, then what be at output? Here D1 and D2, both D1 and D2 are reverse biased. The anodes of the diodes are connected to ground through the resistor R. Both the high inputs set the reverse biasing for that of diodes, and both are switched to off position. Therefore, they do not conduct, causing no current in that of resistor R. Now, the output voltage is just as due to this additional 10 volt. In binary notation, we treat it as 1 and the voltage will be denoted as 1. So, Y is equal to 1. Thus, A as 1, B as 1, we have the output Y is equal to 1. In this way, AND gate is realized by using diodes. So, with the help of this video lecture, we understand realizing logic gates using diodes. First, PN junction diode acting like a switch, OR gate, realizing OR gate by using diodes, and realizing AND gate using diode. So, with this useful and informative notes, let me wind up this session. Thank you.